Hi. In this set, we are given that every day a widget supplier supplies widgets from the warehouse W to 4 locations A, B, C, and D. The daily demand for widgets in each location is uncertain and independent of each other. The demands and the corresponding probability values are given in this diagram. Okay. The example is that at A there is a 40% chance that the demand is of 50 widgets and there is a 60% chance that the demand is of 70 widgets. So there are only two possibilities for each of these 4 locations and the probability for each of the two demands is given. The lines in the figure represents the lines in the figure connecting the locations and the warehouse represent two-way roads. All these lines given are two-way roads. Okay, fine. Connecting those places with the distances. For example, A and B connected by a direct road of 6 kilometers. B and the warehouse are connected by a direct road of 10 kilometers and so on. Okay? The distance in both the directions along a road are equal. Fairly simple thing. Fine. Every day the supplier gets the information about the demand values of the 4 locations and creates the travel route that starts from the warehouse and ends at a location after visiting all the locations exactly once. So he would receive demand of all the locations A, B, C and D, whatever demand be. So he starts from W. He will first of all go to a place which has the highest demand and then second highest, then third highest and then the least one. Okay. Now while making the route plan, the supplier goes to the locations in decreasing order of the demand, that is what was given. If there is a tie for the choice of the next location, the supplier will go to the location closest to the current location. For example, if the supplier is at W and the demand at A is 70 and the demand at C is also 70, all the other demands are definitely less than 70, right? So which will be the first city or the first location that the supplier will go to? The demand is same. In case the demand is same, he will go to the location which is closest. So he will go to A first and then he will go to C. Okay. Now, how will he go to C? There is no direct route from A to C. So also while creating the route, the supplier can either follow a direct path if available from one location to another or can take the path via warehouse. If both the paths are available, the supplier will choose the path with the minimum distance. So for example, if the person has to go from A to C, okay, so from A to C direct route is not there, so he will have to go through the warehouse. Okay, this is one thing. And the last line was, if both the paths are available, for example from A to D, both the paths are available, direct route is also available and via warehouse is also available. In that case, he will choose the path with minimum distance. So direct route is 8 kilometers, but via warehouse it is 7 kilometers. So if the person has to go from A to D, the person will go via warehouse and not take the direct route. Okay? Now, let's start with the questions. Unfortunately, this first question in the set was wrong. Okay, and this was discarded by the authorities. Okay, I'll just explain why it was wrong. The question is, if the last location visited is Ahmednagar, so A was the last location to be visited, then what is the total distance covered in the route? If A has to be the last location to be visited, what should have been the demand at A? The demand at A could not have been 70, right? Because demand at D is definitely less than 70. So A, now how is the widgets going to be supplied? From highest till lowest. So if A is the last, that means A has to have the lowest demand. The lowest demand with 70 is not possible because D's demand is definitely going to be less than 70. So here this means that A's demand should be 50, right? And 50 is the lowest demand of all the 4 locations. Okay. Now if 50 is the lowest demand for all the locations, let's see. Let's look at the demand at D. Demand at D cannot be 30 because then D will become the last location with 30 demand. So demand at D should definitely be 50, correct? Demand at C can be any of 70 or 100. Demand at B Can it be 40? No, because if it is 40, it will become the last location to be visited. So demand at B should be 60. So demand at C is definitely going to be greater than that of B. So if this is going to be the demands, now let's see how is the person going to go. So now what would happen is the person will first go to C because C has the highest demand. After C, the person will go to B because it has the second highest demand. After B, it can go to D or A, both have the same demand. Now if both have the same demand, the person will go to the location which is closest to B. And the closest to B out of A and D is A. So after B, the person will first go to A and not D. So A cannot be, or from A to D, he will go through warehouse and not through direct route. So, okay. So from B, the person will first go to A and then D. So A cannot be the last location to be visited in any case. Right? That's why this question was wrong. Even if we assume the lowest demand for A cannot be the last location to be visited. Okay. So this was wrong question, and this question was cancelled out by the authorities. Let's look at the next question. In this question we have, if the total number of widgets delivered in a day is 250 units, then what is the total distance covered in the route? Okay. So we have to figure out what would be the case where 250 units would be delivered. Now if you look at the minimum and the maximum demand at each of these locations, this is the minimum demand and this is the maximum demand. So the total minimum demand is 190 and the total maximum is 280. So 280 is closer to 250 which is required, right? So let's start with 280. This is the maximum demand, and to reach a demand of 250, we need to reduce demand by 30 units. How can we reduce demand by 30 units? Demand will reduce by 20 units for A, B and D. So if you consider the lower demand for A, B or D, that will be minus 20, and then you need another minus 10 to reduce the total demand by 30. But a reduction of minus 10 is not possible, only minus 30 is possible, right? So the only way you can reduce demand by 30 units is by considering the demand of C as 70 and considering the other demands as the higher values. This is the only way you can get a total demand of 250 units, correct? Now if this is the case, then the highest demand is at C and A. So highest is C or A. So this will be the first location to be visited. The second location to be visited would be either A or C. See, locations would be visited in decreasing order of their demands, right? So CA or AC. Then the third location to be visited would be the third highest, which is B. And the fourth location to be visited would be the lowest, which is D. Okay. Now let's see what is going to be the case. So we'll start from the warehouse, and the first location that we go would be with the highest demand. The highest demand is either A or C. Since they are both equal, we will go to a place which is closer to the warehouse. So closer to the warehouse is A. So we'll go to A, and after A we will go to the second highest demand, which is C, same as A. So after A we will go to C. Now there is no direct route from A to C, so we will go via warehouse. Okay. After C, the next highest demand is for B, which is 60. So from C we will go to B, and after B we will have to go to D. Now from B to D there is no direct route, so we will have to go via the warehouse. Okay. So the total distance traveled is 5 plus A to C, which is 5 plus 12, 17, plus C to B, which is 4, plus B to D, which is 10 plus 2, 12. Okay. So 5 plus 7 is 17 is 22, plus 4 is 26, plus 12 is 38. So the total distance traveled here is 38 kilometers. Right? Let's look at the next question. Now in this question we are asked, what is the chance that the total number of widgets delivered in a day is 260 units and the route ends at Bikrampore. So B should be the last location to be visited. If B is the last location to be visited, then what should be the demand at B? Now demand at C is definitely going to be the highest, either with 70 or 100. That's okay. If B has to be the last location to be visited, demand at B should be the lowest. So can the demand be 60 at B? Well, no. If you look at D, demand at D is definitely less than 60. So if demand at B is 60, demand at D will definitely be less than B. So B cannot be the last location in that case. D will become the last location. So that's not possible. That means the demand at B has to be 40 units. Okay. Now if demand at B is definitely 40 units and we want the total demand to be 260 units. So how is it possible? Let's consider the maximum case for the other locations. So if we consider the maximum demand at the other locations, total demand becomes 70 plus 40, 110, plus 100 is 210, plus 50 is 260. So this total demand comes out to be 260, and this is what we wanted. So this is the only case where we can have total demand 260 and B can be the last location. So what will happen is we will have to visit places in decreasing order of their demand. So the highest is 100 for C. So this will be the first location to be visited. Second location would be A with a demand of 70. Third location should be D with a demand of 50. And the fourth location would be B with a demand of 40. Okay. So the question is, what is the probability of this happening? Fine. So probability, let's calculate probability. What is the probability that C's demand is 100? Probability that C's demand is 100 is 0.7, which is 7/10. What is the probability that A's demand is 70? It is going to be 0.6, which is 6/10. Probability of a demand 50 at D is again 6/10, and probability for a demand of 40 at B is 0.3, which is 3/10. So the combined probability will be 7/10 into 6/10 into 6/10 into 3/10. Okay. So 7 into 6 is 42, 6 into 3 is 18. So we have 42 into 18 is 756 divided by 10000. Okay, 1 2 3 4 1 2 3 4. So this probability comes out to be 0.30756, 0.0756, and to convert it into percentage we multiply it with 100, so this becomes 7.56%. So the probability that B is the last location to be visited and the total demand is 260 is 7.56, option A. Okay. Moving on to the next question. Here we are given, if the first location to be visited from the warehouse is A, then what is the chance that the total distance covered in the route is 40? Okay, see, we have to calculate the probability of this when this is already given. So now this question is a slightly different question from the previous one. Here we had to calculate probability of this as well as this, right? But here this is already given. It is given that A is the first location to be visited. So we don't have to consider probability of A being the first location. That is already given to us. The only probability we need to calculate is the second part. Okay? So let's look at how can A be the first location to be visited. Now for A to be the first location to be visited, see, the demand should be highest possible for A. Now the only problem that would be created by is that C. Now if C's demand is 100, can A be the first location to be visited? Definitely not. There is no other location which can have a demand of 100 or more than 100. So C's demand 100 is not possible if A has to be the first location. That means C's demand should definitely be 70. Okay. And now if C's demand is 70, A's demand should be at least 70 or more than 70. So demand 50 is not possible. Demand 70 is the only case possible. Okay. So for A to be the first one, A's demand has to be 70 and the second place will be C with the same demand of 70. See, what will happen is, if when A and C both have a demand of 70, the person will start from warehouse. He can go to either A or C because they have the same demand. But since A is closer, the person will first go to A and then go to C, right? As we did here in the second part, right? So this is going to happen. Now this is given to us. So we don't have to consider the probability that A's demand is 60% probability and for C the probability is 30%. We don't have to consider this. This is already given. The probability that we need to calculate is now for this part. Then what is the chance that the total distance covered in the route is 40 kilometers? Okay, so let's see what is the total distance covered so far when the person starts from warehouse, goes to A and then comes to C. The total distance traveled is 5 to go plus 5 to come, 10 plus 12 to go to C. So 10 plus 12 is 22 kilometers. So 22 kilometers have been traveled so far. Okay, that means for the remaining two locations, what is the distance that is remaining? Total distance traveled has to be 40. So the remaining distance to be traveled is 18 kilometers. Now how can he travel 18 kilometers? Let's see. Now after C, the next possibility is to go to first D and then go to B, or to go to B first and then go to D. Okay, let's consider both these cases. If the person goes to first D from C, if the person goes to D first and then B, the total distance traveled will be 6 plus 2, 8, 8 plus 10, 18. So D to B, 18 kilometers can be traveled. But if the person goes from C to B and then to D, what is the distance traveled? 4 plus 10, 14 plus 2, 16 kilometers. But this cannot be the case because we want to travel 18 kilometers. Hence we need this case. Okay. So we want to calculate the probability of this case that the person goes to D first and then B. Okay. So the demand at B should be the lowest possible and demand at D should be greater than that of B. Fine. So let's see. Now demand at B can be either 40, 60 and demand at D can be 30 and 50. So this demand should be greater than B's demand. So if demand at D is 30, 30 cannot be greater than either 40 or 60. So demand at D cannot be 30 because D's demand has to be greater than B. So D's demand has to be 50. And if now 50 has to be greater than B's demand cannot be 60, it has to be 40 only, right? So this is the case, D's demand has to be 50 and B's demand has to be 40. And the probability of these two happening is, for the probability of D's demand 50 is 0.6 and the probability of B's demand to be 40 is 0.3. So 0.6 into 0.3 is 0.18, which is effectively 18%. Option C is the right answer. Please do not get confused that why aren't we multiplying for A 70 demand is with a probability of 0.6 and for C the demand of 70 is with a probability of 0.3. So why aren't we multiplying this? We are not multiplying this because this is already given to us. We don't have to consider the cases where demand is 70 and 100 for C or demand is 70 and 50 for A. No, we don't have to consider those cases because it is given that the demand will be 70-70. Then only A can be the first location to be visited. The only cases possible after this is these two cases, and in these two cases we have to calculate the probability of this, and the probability of this is going to be 18%. Right? Now moving on to the last question in this set. Now in this final question we have, if Ahmednagar is not the first location to be visited. Okay, so Ahmednagar is not the first location to be visited. What this effectively means is that if C's demand is 70, then A's demand cannot be 70. Because if A is also 70, then we had seen in the previous cases, if A and C both have the same demand, we will go to A first, which is not the case. So if C's demand is 70, A's demand cannot be 70, it can be 50 only. Or if C's demand is 100, then A's demand can be either 50 or 70. Now both are possible. So this is what is given. These are the three cases that is going to be there for us to consider. Right? Both demands of 70-70 is not possible. But we are also given that the total distance that has to be traveled is 29 kilometers. Now, if obviously A is not the first location to be visited, it's going to be C, because C is going to have the highest demand. So from warehouse we are going to C first. And now can we go to A? Now after C, if we go to A, what is the total distance traveled? 12 plus 12 is 24. 24 plus 5 is 29. So we have already traveled 29 kilometers out of total 29. So from C we definitely cannot go to A, right? That means this demand is not possible. This demand is not possible. So you have to go to C first. After that you cannot go to A. With this combination, you'll have to go to A, which is not possible, because B and D cannot have a demand of more than 70. So second highest demand will be for A in this case, which is not possible. So first we go to C. So demand at A is definitely 50. That is for sure. Fine. Now from C, you cannot go to A. Either you can go to B or you can go to D and so on. So what is the possibility wherein you travel 29 kilometers? Let's see. So you have traveled already 12 kilometers, right? Out of these 12 kilometers, so out of 29 you have traveled 12 kilometers. So you are left with now 17 kilometers to be traveled. Now how can you travel 17 kilometers? Now if you go to any other city via warehouse after C, that's going to be a very long journey. 12 plus 10 to B, or 12 plus 2 to D, or 12 plus 5 to A. That's going to take very long journey. So it's better either you go to B, from C to B, and then you go to A, and then from A to D if you have to go, the least route will be via the warehouse. This is going to be the least route. So from C to B to A to D, this can be one route possible. Or the other route possible is, if you go from C to D, then you go via W to A, and then from there you go to B. These are the two routes possible for total distance to be 29. See, 12 plus 4, 16. 16 plus 6 is 22. 22 plus 5 is 27. Plus 2 is 29. Right? Or you go from C to D via W to A and then B. Total distance is 12 plus 6, 18. 18 plus 2 is 20. 20 plus 5. Sorry, no, I made... Okay, so here we're not getting 29 kilometers. 12 plus 6 is 18, plus 2 is 20, plus 5, 25, plus 6 is 31. So this is not the best route. The best route is C to B to A to D. This is the best route, right? So for this to happen, the demand at C is either 70 or 100, right? Demand at A is definitely 50. Let's look at the demand at B and D. So demand at A, since C is the first location, A is the third location, second location has to be B, and the fourth location has to be D. So demand at B should be greater than A, which is 50. C is either 70 or 100. Demand at B should be greater than or equal to 50. So demand at B cannot be equal to 50, so it has to be greater than 50, which is 60. And demand at D should be less than or equal to 50. So it can be either 50 or it can be 30 as well. So it can be either 30 or it can be 50 as well. Right? Even if the demand is 50 at D, what would happen is, from C you will go to B, and once you reach B, the demand at A and D both are 50. So you'll go to A first and then you'll go to D. And you cannot go to D first from B when A is closer. Correct? So the total demand, what can it be? Let's see. The highest demand possible in this case is 100 plus 60, 160, plus 100 is 260. The lowest demand possible is 70 plus 60, 130. 130 plus 50 is 180. 180 plus 30 is 210. And what is the other case possible? If you consider the higher of this and the lower of this. So 100 plus 60 is 160, plus 50 is 210. 210 plus 30 is 240. Or if you consider the higher of this and the lower of this, 70 plus 60 is 130, plus 50 is 180, 180 plus 50 is 230. So these are the total demand possible for that day. And if you look at the options, only 210 is there in the option. So a total possible demand of 210 is possible, right? Option A is the correct one here. So that's it for this set. Thank you.